If we were to take a look at the memory map for an HCS08, we'd find that RAM goes from 100 up. And what we see here is we're putting values into RAM, 41, 42, 43, 44, and so on up to 50 in hex. And what we're seeing over here is the equivalent ASCII characters being displayed. For instance, I put a 41 in, I get an A. Put a 42 in, I get a B, and so on up to 50 hex, I get a P. So you can look up these hex values in any ASCII chart and you will see exactly these characters. Now, if you remember when we took a look at the memory map for the Freedom K64, RAM starts at 1FFF0000. And what we did, same thing, we put 41 through 50 into these addresses. But notice the ASCII characters that we get out here are not the same. Actually, they're just not in the same order. 41 here should be an A, but notice the A is over here. 42 should be a B, but the B is over here. In fact, what you're going to find is that the 32-bit number that you've got here is in reverse order, because this, when we look at 1FFF0000, this is this address here containing the 44. Address 1 is here, which contains the 43. Address 2 contains the 42. And address 3 contains this. This is address 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So in groups of 4, everything is reversed using this scheme of putting values into memory. The one that seems most intuitive, where we're putting in values in consecutive order here, is called Big Endean. When we take a look where we're reversing everything in groups of 4 here, this is called Little Endean. And what you find is ARM-based processors tend to have Little Endean as the default memory scheme of storing information. This can be changed, but this is a default for most ARM-based processors, including our Freedom K64.